Hello, my name is Budi, and I'll be presenting my term paper on IoT Networking for Smart Buildings. So why implement IoT for buildings? Turning buildings into smart buildings can help building operators with decision making as data from IoT can provide actionable insights, such as reducing aircon usage when there's nobody in the room, or it can help predict when certain things will fail so you can do proactive maintenance. All this can help make a building more sustainable and of course save money. But implementing IoT to make a building smart is also straightforward. For example, there are many network topologies to choose from. Also, there are many kinds of standards, protocols, and hardware, all with a different set of trade-offs. Lastly, how to deal with vast amount of data that is generated from the sensors. These are challenges that require forethought to successfully convert a building into a smart building. Moving on to network architectures. In the literature, there are many kinds of network architectures for IoT, but the prominent ones are edge computing and fog computing. Edge computing is essentially processing data where they are at, and this can reduce latency and bandwidth usage as lesser data has to be transferred. For example, a node that senses temperature can locally adjust and process temperature rather than sending it elsewhere for processing. As for fog computing, sometimes we need to send data to the cloud. These nodes in the fog can help facilitate with that. As for network topologies, the common ones include star, mesh, and tree. Moving on to communication protocols and standards. So, on the physical layer, we can broadly categorize them into two types, short and long range. The diagram explains clearly how they compare to each other in terms of speed, power versus range. Of course, the further the range, the slower the speed. But we also need to take note that high speed may also mean that they take up a lot of power, making it unsuitable for battery-powered IoT. Also, for example, if you want high bitrate video streaming, there is no choice apart from Wi-Fi. Whereas if you are doing infrequent data exchanges, other protocols like Bluetooth Low Energy might be suitable. As for application layer, there are three main protocols, namely MQTT, CoAP, HTTPS. How to choose? It really depends on your use case. For example, if you need low latency, HTTP is not suitable as protocol is more complex than MQTT, which means that IoT need to do more packet processing, making it slower. Now that we have talked about the network-related stuff, we can move on to physical hardware itself. As for hardware platform, there are three main kinds. So the first is building management systems, which can be thought of as the brain. So some industrial controllers include Siemens Apogee and Johnson Field equipment controllers. Next, we have the industrial IoT gateway. They have functionalities like protocol translation, bridging, data aggregation, routing, and others. Examples include Dell Edge Gateway 5000, which is designed for harsh environments, and it offers protocol translation. So sometimes we have too many devices and some may use HTTP, some MQTT. Having this gateway will simplify that as IoT can continue to operate per usual without ever to change protocol. Lastly, we have development boards like ESP32 and Raspberry Pi. Another problem with integration is that there are a lot of data that is being generated, even if the number of devices is little. A lot of time series data will be collected and stored, such as temperature readings, which can be a lot depending on how granular you want it to be. To store those data, we can use databases designed specifically for the time series data like InfluxDB and TimescaleDB. As for stream processing, due to fluctuating network conditions, they can provide reliable data transfer. They typically reside on the fog layer, facilitating transfer to the cloud. Examples include Apache Kafka and Redpanda. So we put everything together, what we have learned. This is how a simplified architecture will look like. At the edge layer, we have our IO key, and the fog layer, we have streaming frameworks like Redpanda and Kafka. This layer can be also thought of as a single floor. For example, for a large building, maybe each floor can have their own fog layer, and each fog in-floor sends their data to the cloud. In fact, we can introduce another intermediate fog layer on top of that if we want to. Finally, at the cloud layer, we have the big databases like InfluxDB for long-term storage. This architecture also scales well with multiple buildings. Centralized systems are simple, but hybrid edge and fog computing improves performance, scalability, and reliability at the cost of complexity. Building operators must weigh these benefits against costs and maintenance needs. While IoT advances may simplify choices, balancing technical and practical needs remain essential. Thank you.